Hi everyone, welcome back. This is going to be our second lesson over functions and function-based programming. Functions are an extremely important part of both computer science and mathematics, particularly algebra. So let's take a look at an algebraic approach to function programming. So first thing I want to do is make a module called Algebra Functions or Algebra Fun, right? So I saved it as Algebra Fun. And I want to make a series of functions that we can call and test them out. And then I want to practice using them in a program. So first off, let's go ahead and look at the shell and let's review the fact that Python is a powerful calculator. In fact, it's one of the most powerful calculators in the world and is being used by engineers and scientists all over the world right now to solve problems. At its simplest level, we can use Python to add, to subtract, to multiply. We can also square numbers by using the star twice, as you can see there. I can also put things to even higher code by doing 2 to the third, which is 2 times 2 times 2 is 8. Now, when I need to do more math than this, I'll need to import a module, similar to the module we're going to write, which someone else might import in order to do math with. So I'm going to import the module math. Now, because I didn't say from math import this function, I just said import math, I've opened up the math module, but I haven't actually loaded any of it, so I'll have to call every function in the math module by saying math dot. So for example, math dot squirt, which is now available to me, will take the square root of 9. I have all sorts of other things. Perhaps if you're in geometry, you've learned about cosine. This angle will be measured in radians. So I'll need to put in something like, 1.0 radians. And that should be somewhere around, 0.5-ish. And there it is. So we have lots of different commands that we can do here with the math module. So when you want to go beyond just basic math, you need to import that. Of course, we can also import specific functions. From math, import squirt. You've already seen us do that when we imported some of the functions from the turtle module. The only advantage really to doing that is that now I have squirt that I can access directly. Like so. If I have the name of the module, like math, and I hit the period and then the tab, it brings up a list of different functions I can use. And this is really helpful. One of the reasons why I enjoy just importing it, so I can sit there and thumb through these things and see all the different stuff I can do. For more information about how to do it, I would need to go to the math class documentation. So there's lots of stuff here. Logarithms, POW, remainder, tangent, all sorts of stuff. Lots of interesting things here, actually. Here's one that's kind of interesting. Hypot. And if I put in 3, 4, it gives me 5. That's the hypotenuse of a right triangle with sides 3 and 4. So that's kind of cool, right? Okay, so just a basic review of math. Actually, before I forget, a couple more things. Important to remember that division is always a decimal in Python. If you want to do integer division, you need to do 2 divides. But keep in mind that that's going to give you answers like 7 divided by 4 is 1, because that's the whole number portion. Another important operator is the percent sign, which is the modulo. That gives you the remainder when you divide by 4. So since 4 goes into 7 one time and has a remainder of 3, 7 mod 4 is 3. All right, but enough of that. Let's get back to functions. Let's add some new functions that we can do. The first function I want to do, I'm going to make a comment by hitting the pound sign, is that I would like to make f of x is equal to 4x minus 10. That's how we'd write it in algebra class, but a computer doesn't really understand that very well. So first, we have to say def f, that's the name of my function, and then the parameter is x. And then we put a colon, not an assignment sign. And now we go in and put down what we want. So I want to do 4 times x minus 10, get that result, and output it to the user. I could certainly just print it, but in general, we want to return it so that the user gets to decide, do I want to print it or do I want to use it again? Once you print something, it's kind of lost forever to the console. It's like writing on a piece of paper and posting it on a wall. You can't go back and get it later. So I'm going to say return 4. I can't say 4x. Python doesn't know what that means. I had to say 4 times x, then minus 10. Let's try out our function. So in order to try it out, I can either code it, I can test it here by writing something like f of 3. And you'll see when I run the module that it should output, actually it won't because I didn't tell it to print. I'd have to say print f of 3, excuse me. Remember, when you want to see something in the program, you have to say print. And you can see that that's 2. But now that we've run the module, we can just say f of 3, and it'll output the answer right there. Because we're not in the program, we're in the active shell. I can do f of 9, f of 24, 25. I can do all sorts of things. I've loaded that function f, and now I can use it. Well, let's get rid of that. That's not pretty. I don't want to have that there. Okay, so let's take a look at a couple more things about f. So how about f of 2? F of 2 is negative 2, and what is f of 3? F of 3 is a positive 2. So since I've got a negative 2 and a positive 2, it makes me think that there must be a place in between 2 and 3 where f of x is equal to 0. That's called an x-intercept, or more formally, a 0. Zeros are really important in algebra. So let's write a program that can find the 0 of f. I'm going to do that here in a function called main. The main function is the function that we want people to run because it's the main function. F of x and the other functions we're going to write are functions that we are writing to use, but they're not the main entryway that we want. It's not the program itself. Main is where we're going to have the step-by-steps. Do this, do this, do this, which for us is going to be call this function and do this and do this and do this. So the first thing I want to do is I want to find this 0. So what I'm going to do is I'm going to write a loop that loops from the x value of 2 to the x value of 3 by a small amount and see if I can't find where f equals 0. Now, unfortunately, you might be thinking, why don't we do something like this? Unfortunately, that doesn't work. Python does not allow us to increment by 0.1 in the range function. We could do some other things to make that work, but it ends up being more hassle than it's worth. So instead, let's let x, let's make a variable called x start at 2 and use a while loop. So while x is less than or equal to 3, I'm going to print f of x. And now this x here is different than this x here. This x is written and belongs in the main function, excuse me. This x belongs in the f function. So there shouldn't be any confusion there. They're called local variables because they're created inside a function. They are local to that function. Now I want to change x by just a small amount. I'm going to say by 0.01. So x plus equals 0.01. And now I'm going to run my function, my module, and I'm going to call main and see what happens. Okay, so we have a lot of information here. And we're looking for when it equals 0, right? Well, I got some negative numbers, right? And then this number here, well, this is scientific notation, which means that in order to find this real value, we're going to have to move this decimal 14 places to the left. So that's really 0.000000004. So that number is basically 0. So I'm thinking that we have found the value that makes this that makes that 0. So but the problem is that I'm having is that it's just not rounded very well. And I need you to understand that floating point numbers, which is what we call real numbers in Python. Numbers that have a number, a decimal, and the numbers at the decimal. Floating point numbers are not 100% accurate. They are very accurate, but they're not 100% perfect accurate. They have to be rounded to be accurate. So we're going to round this. So I'm going to say round. Round is a function in Python. It takes two parameters. The first one is what do you want to round? The second one is how many decimal places. Let's round to 3. And now let's run it. Oh, I ran it, but I didn't run main. Let's run main. Okay, things are looking a lot more up here, aren't they? Okay, definitely. Negative 0.0. We know what that is, right? That is 0. You can't have a negative 0. So there's the value. That's it. The question is, which x is that? I guess we could count and try and figure it out, but that's not really cool. Remember that when we find out when we want to print more than one thing, we separate them by commas. So we're going to print x, comma, f of x. Let's try that. And then I'll type in main again. All right, you can notice that the x value, as we increase by 0.01, again, these floating point numbers aren't 100% accurate, so we're getting some issues. Still pretty ugly, right? Let's go back and let's round that as well. So I'm going to round x, and it should be rounded to 2 decimal places, since that's how many we're actually doing. Okay, and again, I have to type in main to make it start. Okay, now let's take a look. So here are the x values, and here are the f of x values, and you can see they're getting closer and closer and closer to 0. And there it is. So 2.5 must be that x value. I'm going to print that out. Print the value of x that makes f of x 0 is... Now when I want to print out two different things, I just hit comma, and then I put the x. Oh, you know what though? That's not going to work because I need to type in what that x was, 2.5. There we go. I guess I could just put it right here. I don't have to do that. I was excited to remind you that you can separate statements in a print with a comma, but I don't need to. No, because x doesn't stay 2.5. We just need to go ahead and say it. All right. So now I can print out my work like that. Pretty good. Perfect. Okay. Now, so you see how we're using Python to solve algebra problems. One thing I think you're probably getting tired of is us having to type in main every time we want to run a program. Do you remember that there's a way to make it do it automatically? We say if underscore underscore called dunder. These are dunder methods. Always makes me think of Dunder Mifflin from The Office. Dunder methods. Or dunder functions. Same thing. So if name equals main, run main. And I'm going to tell you, this needs to be the very last 2 lines of code in basically every module and program you're going to write from here on out. So there you have it. Okay. Now when I run it, it should just run itself. Perfect. Okay. So that task is done. Let's make another function. Okay, so I'm going to go up here. I'm going to say def, and I'll call this function g of x. We could call it f1 of x and f2 of x, but I'll use a different letter. And we could also have functions that use more than one letter. We'll check that out as well. All right, I want this function. Let's write it in plain English first. G of x, remember comments are ignored by the computer, is x squared minus 1. X squared minus 1. That means exponent. But this does not mean exponent in computer science. This is actually something very different. So we can't use that. We have to use x times 2. That's how you put in a power in in Python. Okay, x squared minus 1. All right, let's run it, and then it's going to do that other stuff. we can now simply say, let's see here, g of 5, 24. Because 5 times 5 is 25, minus 1 is 24. All right, well, I've got a new problem for us to solve. Excuse me. And so this is getting kind of crowded in our main function. I don't want to put a bunch of work there. So I'm going to call this problem 1. And I'll make another function for that. So def problem 1. Oh, you know what? I didn't mean to do that. Let's call the main here problem 1. And then we'll say def main, and main will call problem 1. And look at how convenient this is, because I am going to be working on, I want that to print out, because this printout is going to be really important to me. Maybe I'm turning it into a society of mathematicians or a group of people to show them my work. But while I'm working on problem 2, I don't want to print out problem 1 every time. It might take too long. So what I'm going to do is called commenting it out. I'm just going to put the hashtag in front of problem 1, and then I know that it won't call this anymore. So I can run it, and it's not going to do it. Oh, it's not going to do it. It's going to get mad at me because I have to have something. So I can say pass, So you see nothing happened because I've called the hashtag on problem 1. So let's call problem 2 now. Now, okay, in order to, it's going to get mad at me unless I write a problem 2. So let's write a problem 2. Def problem 2. So you see we've got our functions maybe up here at the top, but then we've got our work for the problems that we're solving also as functions. Functions and more functions. Okay, so here's this problem. It turns out that while this function here, 4x minus 10, equaled 0 for one value of x, some functions, like g of x, can actually equal 0 in 2 places. So I want us to find both of those. And we're going to do that by counting up and counting down. So here's what we're going to do. We're going to write a loop. We're going to say x equals 0. And I want to say while x is less than or equal to 2, I want you to print. Actually, you know what? We're gonna do a little differently. How's that? We could do. Well, let's do that, and then I'll show you how we'll change it. So we're gonna print. What was the name of our function? G. So g of x, and let's round it. We'll round it to 2 decimals. And this time let's just have x increase by 0.1. Okay, so let's run this program now. Let's see if that works. Okay, so you see we've got some negative numbers, and then we get that negative 0.0. That means 0, right? Without a doubt. So we've found our answer. We just got to keep track of what x that is. But what I want to do is I want to show you that there's some other things that we could do. We could also make a list, values, or even what you call a table X, table Y. Make each one of them a list. We've learned about lists, right? And then what I'm going to do is I'll say table X dot append X, table Y dot append F or G of X. And let's round both of them. Round. And let's round this one. You wouldn't think it would need it, but remember, floating point numbers are not accurate in the last digit, so that you can get some pretty ugly answers if you don't round them. All right. Then when we're done with that, I'm going to print them out. Table X. And I will print table Y. Okay, and so they're not really formatted very well because of how zoomed in I am. But if I zoom out a little bit, I think you can see how these are the x's, and we can see how they map together. And this is going to help us find the ones that match. So it's definitely one of these values. You'd have to probably count it up a little bit more carefully. But that's how the tables would go, right? So I wanted to show you that. Let's go back, though, to just printing like we did before. So, and that there are some program things we'll learn later about how to present a list in a very formatted way, make it vertical, and we can make that even look more professional. But for now, let's go back to just printing. So we're going to print x. We're going to print that we're going to round x and then comma, and then we'll put the y value, rounded, of course. Oh, I have too many parentheses. There we go. All right, let's see that. So now we should have, there we go, a nice neat list of our x's and our y's, and it looks like 1.0 is where this function equals 0. So I wanted to find where does x squared minus 1 equal 0. I'm going to add a comment. What are we doing? We're solving where does f of x equal 0. Where does g of x equal 0? And it turns out, though, that it happens at more than one place. So what I'm going to do now is I'm actually going to do this again. I'll say x equals 0. And I'll say, well, x is greater than or equal to negative 2. And I want to do the same thing. Except for instead of increasing by 1, we're going to decrease by 0.1. So now we should see a couple different things happen. So it starts at 0 and it increases, and there's 1, 0. Then we're going to start at 0 and we're going to go down. And you see we found another one at negative 1. So let's print that out. The values of x that make g of x equals 0 are negative 1.0 and positive 1.0. And we found that out in our program, and we have our proof right there. Okay, we got time for one more problem, y'all, but let's write another function. So this function I'm going to call k of x, and k of x is going to be equal to, I'll make this one messy. We'll just do 2 times x plus 15. Oh, let me write it in a more standard version. So 2x plus 15 divided by x minus 1. If this was written in a math book, this would probably be all on top of this. So it'd be like a numerator and then a denominator. But I had to use parentheses. All right, so how would we write this in Python? Well, we would say def k of x colon. We would say return, and then 2. You can't just say 2x, you have to say 2 times x divided by x minus 1. You may notice I'm putting a lot of spaces in between my operators, like the times, add, divide. That's just a personal preference of mine. It does not affect the program. Okay, so let's run it and test it. So I'm just going to comment out. I'm going to comment out this main right here. That called a main. No, I can't do that. I'll say that, and I'll just say pass. So I commented those out. You can't have nothing in a method, so I'll just say pass. Because I just want to practice calling this function. So let's do k of x, k of 5, k of 10, k of 15. Hey, look, they're getting smaller and smaller, right? But notice what happened. From 5 to 10, it went down like 3 almost, but then it only went down a little bit. Let's see what happens when I do k of 20. It went down even less. So what we see is that k is going down, but at a decreasing rate. Well, it turns out that some functions actually get closer and closer and closer and closer to a number the bigger a number you put into it. So let's solve that for our third problem. Let's see if we can find what number k of x is approaching as x gets really big. I'm going to call that problem 3. Def. Problem 3. So what I'm going to do is I'm going to use a loop. This time I will use a for loop because I'm only going to be using whole numbers. So for x in range, I want to start at maybe 100. And I want to go out to 1,000. So I'll put 1,001 so that it actually reaches thousands. And I want to go up by 100. And I'm going to print. And I'm just really interested in the k of x problem. So I'll say k of x. All right. And I don't really want to round it. I really want to see the decimal. So let's see what happens. Okay, so looking at when x is 200, we're at 2.17. And then it's getting closer and closer as I get bigger and bigger. What's it getting closer to? It's getting closer to 2, isn't it? Well, maybe you don't believe me. Let's add another 0 here. Let's go further. So look at as these values are getting closer and closer and closer to something. And the further I go, the more this is getting closer and closer to 2. See, some functions do that. They have a value that they approach. So now I'm getting even bigger, and you can see these numbers flying. I'm getting closer and closer to 2. Let's go even further. This is going to run for a little while. It's doing the math for us. I think it's becoming very certain that this function k of x must be getting closer and closer to value 2 as I make the x values get bigger and bigger and bigger. Which was my third problem, to figure that out. So let's do that. I'll leave that running while I type here. Well, so let's put our answer. As x gets larger, k of x gets closer to 2. And that's the answer that we solved. That was our problem, to figure out what value it gets closer and closer to. Now we can uncomment each one of these and see how they go. I'm going to put this back at a reasonable size, though. And now I've got all my work, and I could turn this into a teacher that was doing a computer-based math class or something like that. But we've got all of our work here where we found the zeros. We found both of them for g, and we found the value that k was getting closer to. Just want to point something out before we leave that I think you can play with, that we are not set to only, one input. We can do things that end up being like three-dimensional functions as well. Like, for example, see, if I done h of x comma y, I could return x squared plus x times y plus y squared. There's no reason why I can't write a function that uses more than one variable. That doesn't use more than one variable. I can say h of 2 comma 3 now, and it's going to actually do all that work for both of them. 2 squared is 4, 2 times 3 is 6, 4 plus 6 is 10, and 10 plus 9 is 19. So there it goes. So that's something to think about as well. All right, so this is functions. I'm going to give you something similar to do, and you're going to do some algebra for me. I can't wait to see how it goes.